Okay, let's get started. Welcome back. This is the Sunday, day 2 of the second session. And today's kind of interesting. We're going to go through a bunch of miscellaneous topics. We're going to talk about swing. So we're going to do lectures 8, 9, and 10 on swing, network programming, and garbage collection, and some miscellaneous topics. And then kind of wrap things up in terms of object orientation. So the first lecture is going to be on the user components, or swing, which is going to give you the information that you need for the fourth and last assignment for this course. Because if you remember from yesterday, you don't have to do number 5. So. It's extra credit if you want to do it. Hey, good, you remembered. Bonus points. Extra credit of 5 points if you do it. Okay, so just like we had the Java util that gave us all the containers and all of the special stuff in terms of the utilities for data structures, the most important part in terms of swing is the class packages with Java X, which is kind of different. It's got an X on there, Java X.swing. If you go Java.swing, which is common actually, you'll get an error message because that package doesn't exist. So classes from package Java X. Why did I put an X there maybe for X windows? I don't know. And the X is basically telling us it's the graphical user interface packages. And swing, why did I call it swing? Another good question. Well, it defines the various GUI components. Swing, GUI, maybe swinging from trees, I don't know. I don't know what the X or the swing could possibly refer to, but maybe if you look it up online, there's probably an explanation for it. So objects for which the user interacts via the mouse, the keyboard, and other output and input devices. Some basic GUI components that are part of it. We've got the JLabel, which puts something out on a window box. We've got the text field. We've got the checkbox, combo box, list, and panel, among other items. These are the ones I'm going to focus on. There are tons of other components. Interesting thing is this J, capital J, that appears before everything. All of the components, if it's a label, a checkbox, multiple select box, imagine everything's got a J in front of it. Most of the swing components are written completely in Java, so they can provide a greater portability and flexibility than the original GUI components from the package java.awt. So before we had swing, we had AWT, which is Abstract Window Toolkit, which wasn't always written in complete Java. It was written in a Microsoft/Java kind of C++ kind of interface. AWT is still being used, still being supported. It's in the Java package. Swing was sort of an add-on from the original. So originally we had AWT, and then we had more of a swing component added to it to make more cross-platform compatibility. Problem, and I'm not going to say problem, but the situation with AWT, the components are platform dependent. So if we made an application for Windows, it's going to run on Windows. It's not going to run on the Mac. Swing is not platform dependent. It's independent. So we can write one application, kind of like the concept of an applet, and run it on any Java JVM environment. So that's why swing won a lot of preference over AWT. AWT is still being used, however. Has some special, and we'll see today some of the AWT components will be used. Some of the swing components are still platform dependent. As an example, JFrame of swing is platform dependent. So the word mostly should be in here. Most of the swing components are written completely in Java. Not all. So JFrame is an example in which we'll see JFrame is the main window, is still platform dependent. So we're still struggling with trying to make it true cross-platform compatible. The problem is every one of our different platforms has different window interfaces, different motifs. It's really hard to make something cross-platform and independent in concept. So common superclasses of the swing components, we have Java lang object. As I mentioned yesterday, everything is inherited from object, even this. The Java AWT component, and what we're doing is we're creating a component. We're putting a container inside of it, and then we're making a J component inside of that container. So we're really still using both. in terms of the hierarchy. So AWT Swing did not replace AWT. So people who are first learning this, they kind of go, I don't use AWT, I use Swing. And no, you're using both, actually. So the hierarchy is kind of going like this. We've got component, then we've got container, and I'm going to talk about component and container in a few minutes. And then we have the Swing J component, which is a Swing component, sort of like Abstract Window Toolkit component, but it's writing inside of container. So the component class, let's take a look at the component class, operates common to most GUI components and are found in the component class. Component class is just saying, let's make the environment aware of the capabilities, and these are the components that we're dealing with in terms of the interface. Well, some components might be the window, the title that's on the window, which would be a property of the component. Everything inside of the window would be contained in that component, versus another window that would have a different container to it. And the container is the wrapper for all of the items, which is why we have a component and a container. So basically it says, object, give me a GUI component, and the GUI component contain these objects, which is essentially the logic we're working with. Once you get familiar with the terminology and the hierarchy, you just do the same thing over and over again. Every single application has the same kind of format to it, and we'll take a look at a sample application. The container class, there's two important methods that originates in this particular class. The add, which adds components to the container, and then we have the set layout, which enables the program to specify the layout manager, that a container position and size of its components that it contains. So the set layout, which is going to give us, is everything word wrapped to the left, to the right, is it centered, and then we're being able to add things. So we're not doing that much functionality. We create these objects and then we add things to the component, to the container, and then we add the container to the component. Okay, so what I'm going to do is kind of go through these GUI components here, and also noting that we have a lot more, but these are some good examples to start with, and this is all you essentially need for most applications. So we have the concept of a J label. It's a label, just like Visual Basic label, just like any other type of label. J label object provides text instructions or information on a GUI display. It's a single line usually, read-only text. It's not editable. If you wanted to do that, you'd go text box. If you wanted to actually have the user enter in text. Images, or both text and images, can be displayed in a label. So you can have a label that looks like a button that shows a picture, and then underneath that have some text or something. Example code. I'm going to show you the example code when we're all done, actually. One thing to emphasize is you don't have to explicitly add a GUI component to a container. The GUI component will not be displayed when the container appears on the screen. You actually have to, once you add stuff to the container, you have to actually display it, which I'm going to show you as well in terms of the examples. If the container is invisible, none of the components inside of it are going to be visible. Which is, well, people put all this stuff together, and then they go, how come nothing's showing on the screen? Because you didn't add the component to the container. Well, the container is not visible. The container is not being shown. So you can turn on and off major parts of the GUI at different levels. To make an interactive GUI program, you're going to need components that accept input, which are going to be buttons, windows, menus, and then you have to actually add events to capture mouse clicks, windows closed, buttons clicked, and all of the other things. Classical event-driven behavior uses event listeners, which are interfaces, and event handlers, which are methods. So to listen to an event when it's triggered, perform some action to handle the event when it is caught. If you think about the try and the catch and all the things, it's similar, but it's not exception handling. Instead, it's event listening. It's like, wait until somebody clicks on this button when the button is clicked. When we have the event ready when the button is clicked, we invoke the listener, and the listener all he does is queue up the events. So it's kind of easy. It's not like we don't have to queue up every event. We just wait for an event to occur, then we figure out, well, what event occurred? Oh, it was a button click. And then we process the code for the button click. That's the event modeling, or the event handling model, which I just described, actually. So some GUIs are event-driven, generated events when the user interacts with the GUI. moving the mouse, clicking a button, typing in a text field, selecting an item from a menu. It's all event-driven. So when a user interaction occurs, an event is sent to the program. Many event types are defined in the package event. So we actually add Java AWT event, and then we have the Java X swing event. We can catch it at a swing level, or we also can catch it at an AWT level. You're going to use one or the other. You don't have to use them both. Some event classes here in the AWT event: action event, container event, key event, mouse event. Because we want to basically say, well, what event occurred? We have a key, we have a class level or a key level, event text, somebody typed in the text box, somebody clicked on this, somebody closed that, somebody moved the mouse. So here is our event listener interface for the package AWT event. It goes from Java lang object. Everything is inherited from that. This says Java util. Let me make this a little bigger so you can actually see it. It says Java util event listener, which is coming from the utility class. In there, and that's the one we've seen already that gave us container and gave us, it gave us the collections is the word I wanted to use, all starting with C's. We have action listener, adjust listener, component listener. What you're going to do, focus listener, item listener in a list, let's say. What you're going to see is you're going to find which event you're going to need to work with in terms of the activity that you're trying to track and handle. And these are not going to memorize. You're going to look it up. You're going to use the one that's appropriate. And you're going to have to find that out. And through practice, you'll remember common ones that occur that you like to do in terms of your activity. So there's three parts of the event-driven mechanism. We have the event source, which is the GUI component, which the user actually interacts with, the button. The source was the text box, the button, or something. The object, encapsulated information about the event that occurred, the occurred event. And the listener, which is an object which is modified when the event source, by the event source when the event occurs, and provides a response to the event that occurs. So the listener says, look, somebody clicked a button. So if they click the button, do this. If they right mouse click the button, do that. If they left mouse click the button, do that. If they open the button, close the button, double click the button, single click the button, all the things that could possibly happen in terms of the handling. And where there really isn't that many, actually. There's like, was the button clicked or was it not clicked? If it's not clicked, don't do anything. If it's clicked, do this. So the programmer must perform two tasks to process the GUI event. Okay, number one, you have to register an event listener. So an object of the class that implements one or more of the event listener interfaces of the package, which is going to be AWT event or swing event, as I mentioned before. When you register, you're just making a new object, making a new instance of that object, registering it. Implement an event handler method to handle the event once the event is actually implemented. And the best way to see this is through an example that we'll look at when I finish this slide set. The slide set's pretty short. It's only about 15 slides or so. So when we're done, we'll take a look at this, and we'll take a look at assignment number 4 at the same time. JTextField and JPasswordfield. So I looked at the label, just put something out on the screen. If we want the user to be able to type something in, change the label, modify it, then we have to go with a text field. The only thing difference between a text field and a password field, one's going to have asterisks instead of the words, and the other one's going to have text. So we can turn the password encryption on or off. Encryption is nothing more than a mask, basically putting, you've all seen them. Type in your password, and what you're seeing isn't showing up on the screen. So there's a single line area in which the text can be entered by the user from the keyboard. And these are single lines. If we want multiple lines, we do text box instead of text field. So a text field is just supposed to be a short single line word or something, or phrase that you're going to type in. It can be more than one word, however. So we have entered by the user from the keyboard or text, and can simply be displayed on the screen when the user enters the data into them and presses the enter key, an event has occurred. So an event, action event actually occurs that says text changed, text entered. So if the program registers an event listener, the listener processes the event and uses the data in the text field at the time that the event is in the program, and copies it to a variable or does something to it, depending upon what the action is that's associated with the event. Outside of text fields, we've got buttons. It's one of the other concepts, a JButton. So a button is a component. Everyone is so familiar with buttons from web forms, actually. These are common components you see on web forms. These are clicks and it triggers a specific action. And then there's several different types of buttons. They're all subclasses of abstract button. So we can create buttons with pictures, buttons with text, buttons that are highlighted. I don't know, they have all sorts of different effects to it. They're all action buttons, or abstract buttons, I should say. And command buttons is generated with a J button. It generates an action event. Command buttons, you know, hit here to enter, submit, save, open, close, all sorts of different events that might occur with that action event. Toggle buttons that have an on or off or a true or false value to it. You hit the button to select something, to deselect something. Check boxes are a type of button, actually. We can have groups of check boxes. It generates an item event. And you're not going to go if it's an action event, is it an item event? After you've played around with it for a little bit, you'll get a feel for it. Radio buttons, kind of like the check boxes. Radio buttons is a group of buttons in which one can be selected, generates an item event. So we have multiple select, single select, or on and off type events. What we're looking at here is the J component from swing, abstract button, and then from abstract button we have J button, toggle button, all the sorts of buttons, and then we have check boxes and radio boxes, radio buttons, and all sorts of different things that come from that as well. Here's some more examples. I have some little GUI here. Here's the J combo box. We've all seen those before, where you've got a list of items that show up. Drop-down list that provides a list of items for which the user can make a selection from. It generates an item event. This one was selected. That one was selected. And then the J list, a little bit of multiple. This is a single selection. This can be a multiple selection. I can also create a sublist from it. So J list is a separate list. It supports a single selection or multiple selection. It generates a list selection event when you actually select it. So we have the multiple select or single select. These are generally, can be multiple, it's generally a single selection item. There's different extensions on that class to make a multiple selection. The only problem is they're not going to all show up on the screen. It's a drop down, so you're only going to see one item in that window. So usually when that happens, you see like that star, or you see like a, some code that shows up, says, hey, multiple things were selected, open me up to see which ones, kind of thing. Very uncommon. I don't know why people try to do that. I think this conserves space a little bit, the drop-down list. If you have a form that's kind of tight, a small little area, it's going to take up more room on the form. It's going to be smaller. This is for single, but you can turn that into a multiple if you need it like this, but you can't put that on the screen. So select all that apply. And you have something is selected or something is not selected. Usually ends up being the format for it. Here's the layout manager, and here's what I was talking about before when I said things can be left justified, right justified, centered. We have some default layouts that we can put in. Here's the flow layout as an example. So the layout manager gives us our order in which the buttons are occurring. Is it going to be this way? Is it going to be all on one line? How are they going to be in representation to each other? And how you add them is going to set the order in which they appear. If you added 2 before 1, 2 is going to show before 1. And you apply it to the layout. Kind of crude, but actually kind of follows with Visual Basic and some of the other kind of components. Except we don't have a GUI. We're doing this programmatically. We're actually writing the source code for this. We're not dragging and dropping and sticking stuff on a canvas. So we don't have, but there are some third-party programs that will allow you to do that. So some great Swing programs that will generate the code for you and will allow you to do this in a GUI fashion instead of doing it in a programming line by line of code. All components in the container are positioned by the layout manager, which is the job of the layout manager. Buttons in the above example are managed by the flow layout, which is one of the layouts that are available, the flow layout in this particular example. The default manager lines the components horizontally until there is no more room and then starts a new row of components. So if I made this is the same window, same layout. just made the windows smaller, it word wraps it down to the following lines. Kind of unpredictable, unless you fix the size of that window, how this is actually going to look. Because that kind of gives you a different look than this does. Do you want the user changing the look of the interface? What if you put labels and stuff around here? That might throw the layout off a little bit. After resizing, the Container Layout Manager reflows the components automatically for you. The default is to center the components in each one of the rows, so you can choose the alignment from left to right. Here's an example. We're saying panel, which is what this is coming from, the class that's inherited from this. Panel.setLayout, new flow layout.left, which means make it left justified, make it right justified. If you go to this tutorial down here, which still works, you'll find a bunch of the other layout options that are available to you. So using the panel, potential problem with the border layout. So that was the flow layout. Here's the border layout. The button is stretched. Here's the border layout. Border layout is going, instead of in a panel and sort of flowing it, I mean, it's kind of descriptive of the title of these layouts. Flow kind of words wraps them one after the other. In a border, it goes border to border. It means use the whole screen. But here we have one button. If we had two buttons and we were going to use a border, then it would be like back to back. And there would be no space in between the buttons. It would just be border to border. So the button is stretched to fill the entire southern region of the frame because we put the border at the bottom. We said at the location. So if you add items to the southern region, it will just displace the first button and make room for the second and go border to border. So a solution is to use panels, which is kind of interesting. So a panel, when we create, and imagine it's sort of like stacking stuff on top of other stuff. So we're creating a new panel in here. We're going to put stuff in the panel, and then we can use a flow layout in the panel. So we divide this screen out into different sections or panels, and then we can apply layouts to different panels. As you may have noticed in here, from the panel, we're setting the layout. So we can set different layouts for different panels. You just create a new panel. So here we can use the solution by using additional panels. It acts as a container for the interface element, and that can themselves be arranged inside a larger panel. So we can put panels inside of panels, nest it so we can essentially apply the right layout to the right sections or subsections, if you want to call it that, of the same screen. So to fix the problem of this, to make it look like this, as an example, put some spaces in here and center it. We create a panel. We add the components to the panel. Then we add the panel to the larger container. The code for that would be to create a JPanel-P, the new panel. Add the button, add the button, add the button, and then the frame dot add the panel with the border layout dot south, meaning orient it down to the bottom of the region, because we have a north, south, east, west, just like the regular old compass works. Where on the border panel, we have the orientation set, in this particular example, to the bottom of the south region. So, how do you know all that? You go online and look at the books. Nobody sits there and learns all of the swing components. In fact, this is one of the things that takes a lot of practice, actually, in order to kind of perfect. And these books should work, actually. Let's see. None of these links are clickable. So, creating GUIs, swing, JFC, it's kind of like MFC, Microsoft Foundation classes. We have the Java Foundation classes. Hardly use that terminology. People just call it swing. You know, say JFC, swing, and they say, oh, it's a swing component. Oh, okay. So you're looking at job ads. Oh, must have experience with swing. Okay. Well, it assumes AWT if you've had swing components. But it's possible to study AWT without actually looking at swing, though. So, what's going on here? Starting over again. We don't want to listen to this lecture all over again, do we? Lecture only has 13 slides in it. It's pretty small. So let's take a look then at the fourth homework assignment and kind of imagine how we're going to build this sucker. We'll look at the requirements, and then I'm going to look at some sample code that practically does it for you. And then I'm going to show you something else, actually, and that might be very helpful as well. The goal is not to cheat and download the examples and do it. And if you can't figure it out, and that might be an approach you're going to take, because I pretty much have given you the entire assignment. So and you'll see that in a few minutes. The better idea is to see if you can do it on your own, then you'll actually learn more that way. The assignments are only worth 5 points each, however, which is not that big of a part of your grade. So the goal is not to get the good grade, the best grade possible. If you do it, you're going to get a good grade on it, but that's only 25% of the total grade. It's a small percentage, so it's better to actually learn the concepts, so that way you can pass the midterm, pass the final. So. Okay, in this lab you're going to require to program using Swing, and we're also going to throw in some file I/O, as we've seen from it. And I'll talk about the file. We talked about that yesterday in one of the lectures. So the application is going to be a graphical user interface that looks similar to this. And I'm going to show you a live version of it in a few minutes. Actually, I showed you a preview of it yesterday. It's that JPad program. And the GUI container, it contains several different components. So this looks familiar, perhaps from the lecture I just went over. The JText area component. This is a JText area in which you can type the text, and it's going to display the contents of a file, or you're going to be able to type some text in it. And then we have JMenuBar component. This is the JMenuBar that we're going to add to the same container, and which contains the JMenu. We didn't look at JMenus, but we'll look at them in this example, and you'll sort of see how that comes together. JMenu component, which is labeled File, which means it contains 3 items: open, save as, and exit. That I put together for you. The other JMenu component, which is labeled Style, not in my example, which means even if you do take the cheat sheet approach, you got to add the Style menu. And the Style menu, this is going to contain 2 submenus: the JMenu font type and the JMenu text area color. So to change the font, change the text color, and there's 3 items: plain, bold, and italic. And then we have the text area color, and that's going to be a menu containing 2 submenus: the JMenu foreground color and background color, you know, the text. And at that point you're getting away from text, actually, because you can't have a text item, and HTML will do it. You know, so it's going to be a rich text document. Each container, and I say rich text, it doesn't have to be HTML. You're not writing HTML code, you're actually creating a rich text, because it's going to have formatting information there to set a background color, set a foreground color, set a text color, which your regular old text doesn't have. The example I'm going to show you is going to give you the text. I'm not going to give you a rich text. But you'll see there's 2 different file types, actually: rich text and plain text. So that's a hint as to what it is you're actually editing and how you're applying it. You're required to achieve the following tasks in these components. If you click on the file Open, you should be able to open a file. This is given for you automatically. You can open a file by either double-clicking on the file in the box. This is automatic behavior. Or as you normally do, or select the file and then click Open using the button. Only the contents of the plain file is required to be shown correctly. If it's HTML, it's not going to show. It's just going to be the contents of the text file. And if the file doesn't exist, you know, it should have an error message. It comes back, show a message that indicates such an error has occurred. If you press cancel, the window should close and nothing should happen. Hint: design the open window is not your job. That is done for you automatically. It's already done in a file chooser class. And if you click on that link, let's make sure that works actually. It should bring up a file chooser. It should go to Oracle instead. Can't open it. Download information requested. Let's do this. Let's go like this instead. I know I have 2 there. Let's see. I might not have internet access, is what I'm thinking. I may have lost. No, I have looks like I have access up here. I'm sorry? Very slow. It's very slow, I'm told. It might just be very, sorry, we can't find the document. On a file, now we got to try again. Okay. It is very slow, you're right. The document is not there. Interesting. But I see some other links there, and I believe one of them is going to give us the file chooser. Or the other port you can do is just go online and Google JFile choose class or JFile choose, and you're going to end up with a bunch of different references. And I'm also going to show you an example in a few minutes that's going to give you the text that you can put in the assignment actually to do it. But yeah, it's going to essentially do it for you. As the message box refers to it, you're going to need to figure out which file has been selected, and then read the file into the text area in terms of the option pane class. So let's see. In terms of the behavior for choosing or doing a save as, it's going to be very similar to the open. It's going to use the automated functionality that is part of file chooser. I think it might be called file chooser right now. The hint down here, same as in task 1, the window is manipulated by file choose. If you click on file exit, the editor will close and stop. Program will stop. You should be able to change the font style, the foreground color, the background color. So, and then that's pretty much the end of it. It's kind of a simple kind of assignment actually. So let me show you how you can get some support files. Let's just close this. There we go. Out on the website, if you go into the Java it's working, that's good. Very good. We're still up and running. That's very good. Course materials. In here, you're going to see a little video, a how-to video on it, but you're not going to see any of the files for it, because I can't give you the source code. I'm going to show you in a few minutes. But if you look at the how-to video and you pause the video, you can type it in yourself if you wanted to, if you so want to cheat so badly. Or if you're really interested in cheating, there's another approach you can take. You can go down here and download the lecture 8 and 9 examples, and I'm going to show you that in a few minutes. The next lecture I'm going to talk about is going to get into, or one of the lectures I'm going to cover today is going to talk about how to get information from a URL and the networking features. I believe it's the next lecture, actually. The networking features of Java. And the example 8 and 9 examples is one program that, let me just pop to it right now, that I'm going to show you that is going to do text editing, but it's also going to allow you to go to a URL. It's going to show you a couple of different options and features associated with that. And I'll cover that in a few minutes here as well. But let's take a look first at assignment number 4, which is your task. See if this loads, which it should. Here we go. And I'll zoom in a few minutes as soon as I get to the right file. Assignment number 4. This source code is not given to you. However, as I mentioned before, this is actually being recorded as well. I called it Java Pad, and I stuck it in one Java file. And this is the file. And before we continue with what's going on with it, let me just run it, and I'll show you what this creates. And I believe I ran this for you yesterday, but let me refresh your memories. A little window should pop up. And the window that pops up, it is called File Chooser. It's called My Text Editor. And it has a file menu. It does not have the style menu. But this is a pretty cool looking notepad kind of thing. It's running on a Mac. It will look different on your Windows system. It will have a motif for your Windows. So if I were to run this program in Windows, well, actually it's a Swing component. It's probably not. It's going to look like this maybe. Something similar to it. But this is a text editor. This is a text editor. So it should be able to open and close. And the functionality actually exists if I go save here and I type in myfile.txt. It will create, and I put it on my desktop here, just like I did yesterday, I believe, for this class. And if I go down here, let's just close. Actually, let's just leave that alone for a second. I should see it out here in my file that I just created a few minutes ago. If I double click on it, it's actually going to bring it up in Text Edit, which is the Mac version. I just created Notepad. You'd think it would be a sophisticated program, but it really isn't. I'll show you in a few minutes. We're going to look at all those GUI components I just showed you in the lecture. If I come out here and go, let's just remove all this stuff. I can still open it in here. I can go open my text file. Open, here is that text file. So, it's fully functioning, opens and closes, and it edits text files. So, pretty powerful for your first GUI program in Java. So let's take a look at it. I'm going to close the file right now. Just as you might imagine from the lecture I just gave you a few minutes ago, we have a couple of things that are going on. We have the Java AWT and the event, swing, and file IO. File IO is from the lecture I gave you at the end of yesterday, which talked about that. Let's not worry about that warning that I'm suppressing. It's an Eclipse related warning. It means I'm not doing any file checking on the IO. Anyway, so we have public class Java pad that extends JFrame. That's creating the window. That is a JFrame window, and that's coming from the Swing component. JFrame is coming from Swing. It is supposed to be platform independent. I believe it's platform dependent. If I took this and actually, you can do it yourself. And you can compile it, run it in Windows. I believe the JFrame on a Windows motif is going to look different. It's going to have a different border. It's going to look like a Windows window instead of a Java one. But it could be wrong. It could create the same look and feel. Something tells me it's going to be dependent, however, on the platform. Which is one of the issues we have running with Swing and also with the AWT toolkit. It does create some interesting non-standard, non-platform looking stuff. Most people in the old days, when AWT was around and you ran the program, it didn't look like a Windows program. It looked like a Java program. And that's how you could sort of tell. If you look at this, though, this is one of the examples. Eclipse in the old days didn't look like a Mac program or a Windows program. It looked like a Java program, and it ran slowly, and it didn't actually use any of the operating system class foundations. And going back to what I mentioned before about MFC and JFC, this is using Java Foundation classes, which are built on top of Microsoft Foundation classes or Mac-related Cocoa classes or in some of the other interfaces for GUI components. It's a wrapper on top of the underlying operating system, so it still looks slightly different, but the more modern versions of it looks like you created a Mac program. It looks like you created a Windows program from it. So JFrame is a wrapper. It's an extension of an object for which, because we know about extensions, so we learned about inheritance yesterday. It's an object that's created from inheriting a JFrame, and the JFrame object that we created was called JPad. So, components to be used. This might look familiar. We have text area. So we're going to create, and these are private components. Well, you can notice I'm following the same standard as I've been following in other Java programs. My data members are private, my member functions are public. And I've got a text area, I'm going to call it edit area, JText area, JFile chooser. In the menu, the lecture is outdated, which is why that link probably doesn't work. In the lecture, it was called file choose, and this is good evidence that I need to update that lecture. It's file chooser. They added ER on the end of it in that link. So when you Google it, look up file chooser, not choose, and you're going to come up with better information. So I'm going to create a new instance of file chooser, and I'm just creating new instances of objects like I've created everything else in the past. But because I'm importing the package of Swing and AWT, and these are all coming from Swing, by the way, that I'm able to create these instances. I'm also going to create the actions for the new menu items, and which is kind of different. I mean, in theory, you'd think it would be all related, but we could create the items and not work with any of the event-driven behavior if we want to. We can just create something that shows up on the screen that we can't touch. I mean, if we start clicking on it, there's no activity that performs. So instead, I'm going to create the actions for the menu items. And these are separate objects that I'm going to create, and they're going to be called action, open action. And these are for that menu item that I created, but I haven't created the menu item yet. I just created the actions, which are going to be basically the objects that are going to be invoked. And one of them is going to be an open object, a save object, and an exit object. And then, as I showed you yesterday, the main program just is going to create a new Java pad. I should have put that maybe at the top, or maybe it is at the top of the methods. I could have put it at the bottom. But so when this is created, this is the interesting thing. So when we start working with GUI components, when we start creating the application, when in this new instance of this new object JPad is created, the constructor is going to do a lot more. Because when our DOS-based program, we just were presented with a DOS prompt. We didn't actually have to build a window, put the menu on the window, build a container, add the items to the container, display the container in the component. We didn't actually have to do any of that stuff. We just, we didn't have that. So now that we have that, the constructor, when we create this new JPad object, is going to do a lot more. It has to create the scrollable area. So I'm going to go edit area, which is this object I created up here, and you'll see this is pretty standard to create the objects up here. So we have all the objects that we're going to use in terms of the interface created, and then actually I've mixed and matched it because I haven't really created the menu up here, and then start configuring it down here in the constructor. So we're going to say that this J, we created this. We didn't actually create the object, we created the reference to the object because we said private text area, edit area. I could have said equals new edit area, or excuse me, new JText area. So I made the reference to the object, but I really hadn't created the object. And here I'm going to create the object. I'm going to say text, excuse me, edit area, which is that object of that type, that reference up there, equals new text area. This piece of code could have gone up here, but I don't know, it's your choice. It's kind of common to see all the configuration stuff in the constructor versus in the initialization. And then you might say, well, you didn't do it here. Well, okay, I could have put this in the constructor then instead. So it's a little mismatched. It's a little hacked. It's not exactly perfect. A little inconsistent in some of the things I'm doing, but don't worry about it. It doesn't mean it's wrong. I'm going to set the border here. I'm going to set the font. I can change the font, change the border. And the border is going to give me the thickness of the window of the text editor. I didn't set it that big, actually. I set it kind of small. And you'll go online and you'll look up all of the different methods that are associated with JText area and as an object type, and you can see what you can set. You can set the title of the screen. You can set the, I mean, if you wanted to put a title on it, which I'm not going to do it because that's in the window. It's inside of another component. You can set the border, the font, the scrollable. Is it scrollable? And what you're doing in this particular case is creating a J scrollable pane, scrollable text equals new J, on the editor. So each one of, if you think about the concept, all those things we take for granted when we see the window. It's all separate objects in the window. This left and right, horizontal and vertical scroll bar is something you have to add to the text area. The font, the border, all those characteristics are addable components. To create a component panel, you can set the layout and add the components. So here we have JPanel. So remember I said before we can create panel. We're only going to use one panel for this program because all we have in the screen is this text area that is going to appear on the screen in front of the user. If we wanted, I could put the text area on the top, create two panels, let's say. One is going to be the text area, and the other one might be something else. It might be a bunch of buttons and stuff, and we're going to see that in another example I'm going to show you in a few minutes. But with a single panel, I'm just creating the panel, and then on the panel, I'm going to set the content.setLayout. So content is the name of my panel, and I'm going to set the layout for the panel to be a border layout. We saw that actually in the lecture a few minutes ago. And then I'm going to add the scrollable text to the border layout. And I'm going to make it centered. The border layout is going to center everything. So that text is actually the text area, excuse me, the panel. The layout is going to center the components that I add to that panel. I'm going to create the menu bar, which is another object. I'm going to add to this all these items that are contained inside of this window, the J menu. So the J menu bar is going to be my menu bar. It's going to be equal to new J menu bar. I could have put this, I could have stuck this up here. I didn't. I stuck it down here. I probably should clean this up. Then it would look too perfect. So what I try to do actually is kind of put the items together to show you, create the object and then change this characteristic of the object. Run this method on the object to add a layout and then set the layout to this, then add the layout to this. So, which is interesting because you have to create the object, set a layout for the object, and then add the object to the other object, which is kind of interesting because there's a hierarchy of all of these objects that are appearing on the screen. So this is also not to say it's definitely part of the hierarchy as well. So we created the menu bar, and then on J menu which is going to be our file menu. There's a menu inside of the menu. We have the menu bar, and you're going to create two. You have to create another one called style menu, or whatever you want to call it. I created one called file menu. I could down here create another one and call it style menu, and you're going to have your fonts and your background, your foreground color. This is the part you have to do. Because if you're cheating, you're looking at this video and you're cutting and pasting this code as I'm going through it and you're writing it so you can write this program. Because I'm not going to give you the code. But you can easily get it if you're smart enough to figure out what I just said. Alright, so there's no excuses, by the way, for doing not doing any of the assignments for this course because I practically have done them for you. Alright, so file menu set. This you could probably leave out if you wanted. This is going to be setting a mnemonic. Basically makes the F. You ever seen those DOS-based programs? This is from like Windows 3.0, the beginning of Windows. So what if people don't have a mouse? You can use the keyboard for everything if you don't have a mouse. You can, alternate F, and it would open up the file menu. Well, actually, believe it or not, it's kind of ancient because everybody has a mouse now. Nobody uses it without a mouse. But people have lost their fear of the mice. However, it from the old days, it kind of created this really nice look. It had like the F was underlined, and it stood there was more space between the F and the I and the LE, and it kind of looked better. To get the same motif, which is why I put this in here, it looks more professional. Whether people are going to go Control F, whatever it is, I think it was alternate F or something, I don't know. One of the control keys or the alternate key plus the letter F opened up the menu. It worked like the mouse, essentially. So this is setting the mnemonic. You can do it with the first character, second character, third character. You're supposed to do it. You're supposed to alternate it, actually. So it's a different character for each one of the menu items, just in case your mouse dies or something. Who knows? Outdated concept. Actually, the MFC, the current version of Visual Studio, does it for you automatically. Even though you don't look at the behavior, use it, it automatically, capitalizes the F and underlines it, makes it look like it's something you could do on the keyboard. But if you don't program the behavior, it's not there anyway. So. Okay, I'm going to add these items. And then what am I adding? I'm adding the open action, save action, and the exit action that's up here that I created, these objects here. That's interesting. So you create a bunch of objects and you add some of the objects to some of the other objects, which is what we're doing. So we have these objects. These are going to be the method calls, essentially, that we're going to run when the user from the menu selects the item. So we're going to, from F file menu. So you're going to create another menu item for your fonts, for your style, and you're going to create more of these items up here so you can set the foreground and the background color of your text, essentially, which is kind of tricky. So this is probably the trickier part of the program that I left out. I'm not going to show you. So you set the window context and the menu. So set context pane to content, which is the panel that we created up here, content panel. And then set J menu bar to menu bar. What does this do? If you leave these two lines out, none of them appear on the screen. You go, I created these items. When I open it up, it's missing. Because you actually have to set it. You have to set the window content. Because you're going to have many different other menu items. So here's the trick. So let's say you have a program that's more sophisticated than this. And when you go into a new feature, the menu changes. Not so hard. You just set the new menu. I'm now in the file edit side of this application, or I'm in the print side, so now I have the print menu. Common behavior these days, if you haven't noticed it yet as a user, the menu's items always change to reflect the tasks that you're doing. Now the other option you have is to select or deselect, or you see stuff disappears. People don't like the disappearing because then they go, I can't find the open option. Instead it's grayed out now. Which means all these components are separate objects that are treated separately, for which you have the behavior of adding to the menu, taking away from the menu. Actually, you don't have to take it away, you just have to repaint, set the context differently. The item is still in the program, still available, it's just not visible, so you can't see it. So you set the window context in the menu set, and this basically makes it visible. And then you set the other window characteristics. So set the default close option, exit on close. So we got the, you ever see in the window, you've got the maximize, the minimize, and then the red X in the Windows motif. on the right-hand side normally of the window frame. You can turn it off, actually. You can turn off the maximum, the minimum, and the X. In fact, you could do it in other languages as well. We're going to set the title to my text editor. Pack. It's an interesting question. What does pack do? And people are always going, is that needed? It's kind of optional, but if you leave it out, it's unpredictable what's going to happen. When you pack it, it says package it all up, which basically goes through and does a refresh. It's kind of a method call to the JPanel that says, put everything together for me, so that when it appears to the user on the screen, it's all there. And it doesn't come, here's this one, here's this one, here's this one, which technically would throw an error if it couldn't assemble it before it displayed it. So you put that in there and it throws an error if one of the components is missing. You added something, but later on you took it away, but it still thinks it's supposed to be there. Then you're going to get an exception thrown that's going to say, the menu is missing, or this menu item is missing, or something. So pack essentially is that method that pre-assembles everything, packages it all up, makes it ready to go before the application actually displays it. So you don't get any, it eliminates some runtime errors, makes it all look like it all appears at the same time and all flows correctly. Depending upon the memory, depending upon what's going on, it's unpredictable behavior when the menu actually displays. Like, what part of the menu is going to show first? Your program is going to look kind of hokey if the menu doesn't appear until after everything else is drawn or something. So just set it all ahead of time. Set the location. You can set the location relative to the top of the screen, the bottom of the screen. In the old days, in Windows 3.0, Windows used to open up in the left-hand corner of the window. Now everything's open up in the center. We're not going to set it. So I say null. We're going to put it in there just in case we want to change it. Set visible. Well, we don't actually have to make it visible. We could leave it as invisible, which means the window is built, the window is out there, the object is created, but the user doesn't see it yet. And then when you click on the menu item, you see it. It gives a different, for the main program, you don't want to do that, otherwise nothing's going to show. You're going to make the entire program invisible. When you make it visible, it's easier than loading it from scratch, which makes the application flow a little bit easier. So you build it all, and then you set the visible to true to only the items you want to show, and then false until the item is selected, until you actually want to show the window, and then you show the window. A little easier in terms of the flow of how the application is actually, the speed of the showing of the window is faster, long story short, versus having to go build all this stuff on the fly. You know, if you create all your objects in the beginning and you're not using the objects yet, and you don't make them visible. And then when you start using them, make them visible. So we have the class open action. If we don't make it visible, it's not going to show. I believe the default behavior is true, by the way. So I think that's taking care of it for you. If you don't set the context, there's no default behavior for the context. If you don't set the context to this particular panel, this particular menu bar, then it's not going to show anything. It's going to wait until you set the context to something, which is kind of interesting. It makes it kind of tricky, I think, for new people who start learning it, because one small little logical error, and you're going, well, how did I have to make it visible? Why did I have to set the context of the panel? Okay, so now the rest of this code is going to give us, and this is from the lecture, the abstract action. Everything is inherited from abstract action. So open action extends abstract action, which means we're going to have a method in here for this object, and what we've created is 3 separate objects, the open, the close, the exit, that is going to perform some behavior for us. So it's going to, working with action listener, that is part of event listener, excuse me. So action, abstract action, the constructor to open, it's going to run back to abstract action and perform a super open, which is going to essentially put the values on the screen for O on the menu item. The action is performed, action performed. Here's the key. We have created an action event for an open. So this is automatic behavior that you basically follow the syntax for when you create it. And this is an abstract class, the abstract action, which means you have to implement these methods. If you leave the method out, you get an error message. So if you're implementing, extending open, you have to put an action performed method in there because of the abstract requirement. We have file chooser is going to be a show open dialog, javapad.this. So for this particular program, show a dialog to open files. And all of the activity is actually from file chooser. It's automated behavior for you, already built into Motif. This is what happens. If the retrieve value is a approved option, which means they've selected an approved option, then create file F equals file chooser, get selected file. We're creating a file pointer for the file, which is what we looked at in the last lecture from yesterday for a file IO. Try, this is what we looked about yesterday in terms of the exception handling. Open up a file reader, new file reader F, that pointer to that file that we just created. Text area.read, read it in, use the text component to read it in, catch an IO exception, and we're going to call it IO exception and print it out to the screen if we have a problem. So the file chooser is that GUI object that comes up and gives us that list of files in the directory. And the navigation of those files, the selection of the files, everything all the way down to opening up that file is all done automatically for you by the file chooser. And it's all really the default behavior that you'd automatically expect from a file dialog box like that. The save is going to go through a very similar fashion here, except for it's going to write. It's going to do, instead of a reader, it's going to have a writer. So this is going to have you implementing the file IO stuff that was in that lecture. And if you're looking for clues, all of the code for the file reader, the file writer, if you don't take it from this example, is going to be in that lecture as well that we did yesterday. And this is going to be essentially the same code, doing essentially the same thing, except for it's doing save instead of open. Exit's really easy. Exit's just going to shut it down. So it's going to go system exit. If the action is performed, run this system call to exit. It just shuts it down. Doesn't do any closing, doesn't do anything. You could put a nice little on the action, exit action. You could put a little check to see, has the file content changed? Which means you'd have to do a comparison between the file read and the, what's currently on the screen. Read it and then, perform a little analysis. And then if the content on the screen has changed, slip up a little dialog box and say, hey, would you like to save your changes? Functionality is not in here. You have to actually build it yourself. Which is nothing more than a comparison between what's in that text edit box and what's in the file. If there's a variance, and there's a file compare actually from the file open, you can tell if the file's changed. Like, it's an automatic method that you can run that just gives it the two parameters, text edit contents versus the file pointer content. Is it different? If it's different, put up the dialog, say, hey, when you want to save it, and then run this file save, essentially. That gives you the option and the automation for saving the file. And the saving of the file is done automatically through the dialog, same way as the opening of the file is done automatically. And that is essentially all of the behavior that you're implementing. So the file opening and the file saving and all that stuff's done for you. What you are concerned with at this point is putting in the style menu. So you can add the coloring, and that I'm not going to give you. That's kind of interesting, but it's actually kind of easy. But I'm not going to give it to you because then I'd give the entire assignment away. The other thing, this is one program, this is one file, actually JavaPad. The other example I have for you, the one that says Lecture 8 and 9 example, I took from here just to refresh your memory. This example right here, when you download this file, you're going to get a zip file. If it's on the screen somewhere, nope, I don't have connectivity. Yep, here it is. Called JP Lecture 8 and 9.zip. That file is going to contain this program here. This program is in two sections, actually. I'll show it to you right now. This is Lecture 9. This is Lecture 8. So the text GUI part is a text editor, and the text editor is kind of interesting. Let's see it run first so you can see what I'm showing you. If I run it, and this came from a textbook actually, it's not my example. Here it is. A little bit more sophisticated. Oops, I'm going to try and make this window smaller so it fits. little bit more sophisticated than the text editor that we just built a few minutes ago, the Java Pad one. It still has the same thing, but it has the edit, cut, paste. It's still not going to do any coloring for you, which is why I'm making it available. You can use this if you want, though. If you want to use this and add the style menu to it, that's another option that you have. What this one is setting a slightly different. It's got the the Control O next to it, on the name, but it's really the same functionality. It's doing a file open. It's taking and replacing instead of setting up a dialog. Oops, it's putting this on top of this other one. You can see it underneath it, so it kind of gives you the impression that it's replacing the original program with a separate one. You can still select. Let me take a look here, and if I'm going to find the desktop. You can still select the same files. Oops, we'll just do this one here. And here's that file. And it is actually setting your background color of the window. So, and I forgot to take that out. So I did give you a hint on the background color. The save as. The exit's in a separate window. Excuse me, the edit's in a separate window. There is no exit button. Just notice that. Example text. What's in the example text? Hello world. We can clear the window box. We can select all the text. This is select all. We can do a cut and a paste. And this is we'll take a small break after I show you this example, but this is what we're going to look at in the next lecture. Let's say, for example, we want to go to a URL. This little button here is actually, there it is working. Very good. It's showing me text, though. It's not showing me HTML. This is the text version of the HTML file that I have at bhacker.com. Works with other stuff, too. Google. I don't have the return key. If I did a return on the text box to do it, I actually have to press the button in order to get the behavior to work. Not what I'd call a sophisticated example, but here's Google text, actually. Take Yahoo and stuff like that. So what this example is doing, and let's go back to the example, it's kind of reiterating the point that most of the text editor, most of the examples themselves, let me close this down, actually, that was the last example, look pretty similar. So what are we doing here? We're including the same packages. We got the Java Swing file chooser, which is going to be opening and closing our files. Instead, running in this way, we've got the Java I/O working in here as well. I've got a separate file here for the get URL. I'll show you that after I go over the lecture, and we'll revisit this example for a few minutes. But just to show you the basic file editor that we're looking at. Text editor GUI, which is the name of the class that I'm creating. That's going to be my text editor. Extends Java Swing JFrame. Well, this I could have made it a little easier. I could have gone up here and said import Java Swing, which probably would have been a little bit more standard. But that's why up here, if I took the same header, same packages from that previous example, put them in here, I can get rid of half this stuff. So I don't have to reference this, but I'm only using it for JFrame. So I was just showing you a few options. Private data as well, again, so all the data members are private. And I've got file name is going to be equal to file no name to begin with. So create a new form of the text editor. Here we got a text editor GUI. This is the public method to say initialize the components. This one doesn't use a constructor, you've noticed. So the previous text editor example had a constructor. This one, instead of saying, well, let's just use the constructor for it, the program itself, this constructor here, is running integer components, which is another kind of way to do it where it says, well, if we want to have a constructor, because it's called text editor GUI, this would be the default constructor. Instead of putting this code in here, we created a new method call, and we're running this method call instead of putting it in the constructor. So it has a constructor, but the constructor really isn't doing all the work. Instead, it's calling a method. Common to see this because it's a little easier abstractly to read through. It makes the code a little bit more readable, but you don't have to. You can stick it all in the constructor body. What is this method doing? Wow, we got a lot of components. We have a copy button, which is going to be equal to a new. Again, you could have saved yourself a lot of work by including the javax.swing up here in the package list. Instead of repeating it 25 million times, so this is illustrating a point. Why not just stick it up here? If you stick it up here, add it to this list, you don't have to do this stuff all over the place. And this is a bit ridiculous, especially when it comes to the typing. So you could have saved yourself. But look at all these components. We got the copy button, J-scroll panel, edit button, cut button, paste button. All the buttons you could possibly imagine in that interface are separately defined as separate objects here. And these are all the instances of all those particular objects being created. And then down here, we're setting the default closer operation. We're setting the menu, the exit on close, setting the title to Java text editor, setting the name, mainframe. We don't actually have to set the name of this application or this component. That's kind of optional. So, what do we got here? Copy text, and forget about this comment. It makes absolutely no sense in the context of this example. Set text to copy. Copy button. So this is all the activity for the copy button. If you're interested in seeing, essentially we're just performing an add action listener. If we highlight the text, it's going to allow us to copy it, paste it, cut it, to perform the activities on it. So we're adding the listener. So we have to add the action listener to the copy button. It says on the copy button, when we press the copy button, perform the copy operation. The J-scroll panel, set the horizontal scroll panel, same thing we saw before in the previous example. Set the background, that's how you set the background color. The background color is going to be using the AWT. Fonts will be using the AWT probably as well. If you'd like to do it that way, you can. You can use the AWT to do the font. You can do the background color with it. You don't have to use Swing for that. JPanel, set the view. Set the viewpoint view to the edit panel, so the focus is on the edit panel. You can go through the rest of this text on your own after you download the example, unzip it, you'll get this file along with the next one. We're just creating essentially all the behavior for all the action listeners for all of the different menu options, so that when all those buttons are pressed, all these activities are actually performed. And we're setting a J menu, set the text to file, which is going to show up on the little J menu. Same menu as we did before. We add the items to the menu, then we take, lo and behold, at the bottom of all this stuff we'll be adding all these components. Here we go. Swing group layout. We're using a different layout than we had before, which is coming from group layouts. So we're setting the layout for a panel that we should have created, and get the content panel. Get content panel, set layout to the layout. Layout, horizontal layout, change the layout components, make things relative to other things. This is kind of hard to do manually. We have the pack down here. This is why, and this is a good example, this is why people use those GUI editors. You can get third-party tools that drag and drop components that create this text for you automatically. Only problem is this is actually kind of clean and well organized, sort of. It's a lot of repeated code. It's a lot of manual. Add this item, add the action listener, add this item, add that, add this item, add that. Because it's all done for every single item that appeared on that screen. You have a separate object that's created that's added to another object. So it's a little tedious, long story short, which is why I'm not going to go through all that code. It would take me a couple hours to go through all that code. Instead, I'm going to say if you have an interest in doing GUI development, you find a really nice GUI tool that's going to add the components to the canvas for you and create the source code for you. They're going to be Swing tools. Cannot recommend one because I don't do any GUI development with Swing. Instead, I prefer to do more internet-related HTML development. Because if you're working with JSP, you're working with one of the other Java scripting or Java Enterprise Edition tools, your interface is in HTML, it's not in Swing. So some people say Swing, great. It's nice for applications. See those text programs we just wrote? Nice for that stuff. But if it's an internet kind of thing, and you're going to be working with HTML or scripting languages, PHP, Python, some other front-end component that you're going to be working with. So I wouldn't spend too much time focusing on Swing for your career. Unless you're working for an application developer making applications for PCs that are not internet, not internet applications. So. Pack, add stuff together, kind of interesting. At the end of everything, you always put pack. Generate some errors. And here's all of the methods for all of the actions that are performed on everything. And then we have the save menu item, action for this, action for that. This stuff is coming from a generator. This code was originally created from a GUI generator, which is why some of these comments don't make any sense, actually, in terms of the comments of the code. I probably should have pulled them out, but I left them in to remind myself that when I'm going over this, tell you this was done from a generator program. Nobody wrote this stuff. Are you kidding me? Look how tedious it is. So, all right, so I'm going to wait and go over this URL stuff in a few minutes after I go over the networking lecture, which is the next topic to cover. But as you can possibly see, do not modify, generate, begin variables. Okay. As you could possibly see, a little tedious. Get a third-party tool if you're interested in doing this a lot. If you're going to write one small little component and the functionality is essentially the other objects and the other parts of the program, then you focus on that. There's people that spend their entire life doing Swing development. Possible, you know. Not doing any other type of GUI programming, just Swing-related stuff. So, time for our first break, because we're going to switch topics. So we have gone over all of the assignments for the course. That was the last assignment, number 4. So we've hit all of the assignments. I'm going to cancel that. My screen's still big. Let's see. Our next, and this is Saturday, our next topic of choice, this was lecture number 8 that we just went over, is number 9. Number 9 is on networking, network programming. It's actually not too bad. It's about 15 slides. But it will talk about how to go to a URL, how to get the host name. It's actually quite simple. It's very easy, actually. So let's take a, what do you want, 10, 15? Okay, they used to call them biology breaks. A little biology break. Bio something, I don't know. Bio breaks. It's called bio breaks. You have to go to the bathroom, get something to drink, get the bio working. So I'll see you in 10 minutes.